All right, folks, welcome back. We're done with page 1 of the notes, which was really talking about the sampling distribution of x bar 1 minus x bar 2. And now we're going to move into page 2. And page 2 is the nuts and bolts of our inference procedures. We, of course, will be talking about confidence intervals. We'll do that first, and then we'll scroll down and talk about significance tests. So the type of confidence interval we're doing here, we're constructing a two-sample t interval for a difference between two means. Two-sample t interval. Before I talk about the conditions that are required, I actually want to show you a reference in your textbook. So if you open up your physical textbook to the back cover, you'll see this. I'm going to show it to you in the ebook. So this is what it looks like when I log into the to the textbook publisher website, and then I select my ebook for TPS 5e. Here are all the chapters. Obviously, I'm going to go all the way down here to the appendices. I'm going to open that up. And then this thing here called Appendix 8 End Paper Inference Summary. So when I open that up, you'll see that's the same image that's on the back cover of your textbook. It's 2 pages in the back cover. And this covers all of the inference in AP statistics. We have done much of this so far. We have not done all of it. For example, these things down here, these are chapters 11 and 12. But by the end of this lesson 10.2, we will have covered everything from there up. We have inference for means. Currently, we're talking about 2 means, and we're going to be talking about intervals and tests. In the past, we talked about proportions. 2 proportions, that would be chapter 1 stuff, and then 1 proportion interval, that's chapter 8, 1 proportion test, chapter 9. I want to highlight something here, though, that a student actually asked me a question about, and they said this. They said, Mr. Vass, you got this thing called a 1 sample z interval for p. It's also called a 1 prop z interval. I'm confused because there's 2 different names for the same thing. And I want to jump over to the calculator and show you why we have that confusion. So I'm here at my TI Nspire. I'm going to just add a calculator page. I want to go menu, option 6, which is statistics. Let me just jump down here to confidence intervals. So we have all these different options for confidence intervals. And take a look at the things that are called a z interval. We have option 1, z interval. I'll skip the 2 sample stuff. The other one is 1 prop z interval. Those are both z intervals. They are both 1 sample z intervals. But this is the one that we use, a 1 prop z interval. Why don't we use the z interval up here? Well, let's just jump in and see why. The reason why is because when I open this template, I have to input a population standard deviation. Again, it's unrealistic for us to know that. So it's still a 1 sample z interval, just like this is a 1 sample z interval. It's just named with a different, it uses a different name, 1 prop z interval, just to identify it as being slightly different than the other one. So again, I just want to show you these again because I think it's a area where students can get confused. We're never going to use any of these inference tools that ask for the population standard deviation. So that means we're going to avoid this one, the z interval. We're going to avoid this one, the 2 sample z interval. We will use the 1 prop z interval, 2 prop z interval, the t interval, and perhaps in a few seconds we'll even use the 2 sample z interval. Okay, so let's jump back to the notes. Folks, let's rip through our conditions here. We're going to go ahead and start with random. Then we have the 10% condition. Both samples are less than 10% of their respective populations, and remember, this is required when we're sampling without replacement. Why is that required when sampling without replacement? Because when we have this, then the sample is approximately this. Okay, now let's talk about the third and final condition here. the normal large sample condition. Okay, folks, the normal / large sample condition, we have the central limit theorem at work here. Both populations have to be normally distributed, but if they're not, the central limit theorem will guarantee that the sampling distribution is approximately normal if we have a large sample. Both samples have to be greater than or equal to 30 for that condition to be true. If not, then we need to check for strong skewness or outliers in both samples. And how do you do that? You show a quick box plot. All right, now when the conditions are met, let's talk about the confidence interval. The confidence interval for mu1 minus mu2, and remember what a confidence interval is. It's a plausible range of values for this parameter. Now our confidence interval, this is the same confidence interval we've been using since the start of our confidence interval chapter way back in chapter 8. Confidence interval is a statistic plus or minus a critical value times the standard deviation of the statistic. Well, for the comparison of two means, this is our confidence interval. Notice we have t star, that's critical value for the t distribution with c% of its area between plus or minus t star. Now, in order to use t star, we'll need degrees of freedom. Here's the big question though. How will degrees of freedom work? Two samples. In the past, degrees of freedom was just n-1. Now we have two samples. And here's where I need to share with you some bad news. Degrees of freedom is no longer just a simple n-1. It is now this beast right here. That's bad news, folks. Look at that formula. I find that intimidating. I can't even imagine how you feel about it. I want to give you some a hint though. Folks, don't memorize this formula. It's rarely used. Now it's time for the good news. So let me share some good news with you. We're going to use technology. And specifically on our TI Nspire, we're going to use the 2-sample t interval. On your calculator, that is menu 664. And you know, you should know by now you get two options there. You get data, where you can enter list names. Obviously, there's going to be two lists because we are comparing two different samples. Or you can do the stats option, where you enter sample statistics. And I noticed this on the last test. A lot of you were doing this and writing out the calculator procedure for that. I'm going to ask you not to do that. What I would rather you do is I would rather you do this. At least I'm okay if you do this on a test, but pretend you're doing this one. Okay, make sure you tell me what the sample standard deviation and sample mean were for each of the samples, then report out what the calculator gives you as a degree of freedom and what the confidence interval is. Okay, that's how I want you to proceed with doing that on your calculator. Okay, so that's confidence intervals. We'll do some examples of that shortly. Let's roll down here to significance test. Again, the name 2-sample t test for difference between two proportions. The same thing I said about confidence intervals on the calculator and all the different options that you have to choose from also holds true in significance tests. Those menus parallel each other pretty well. In terms of the conditions, let's just go see the previous. Same conditions as before. The null hypothesis, typically, we're going to use a null hypothesis of mu1 minus mu2 equals 0. Same thing we did with proportions, where we did p1 minus p2 equals 0. Another way to state that is alternatively you can say mu1 equals mu2. So as has been true for all of our significance test units, the test statistic is equal to a statistic minus parameter all divided by the standard deviation of the statistics. When it comes to a difference between two means, it looks like this. You'll notice that the formula down here is a little easier than it was in proportions. In proportions, we had to do this thing called pooling of we had to find a combined proportion, a pooled p hat. We don't have to do that there's no equivalent for that in means, so don't worry about that. Okay. Also, some bad news here. In order to find a p-value for this test, we still need to find that the degrees of freedom with that crazy formula above. Not going to worry about that. The good news is, just like before, we're going to use technology. And the two-sample t-test on your calculator is menu 674. You're going to find the value, the p-value from your calculator. And remember, the p-value is the probability of calculating a test statistic that large or larger in the direction specified by the alternative hypothesis. So it's the probability of getting a sample result that large or larger. Again, I stress the definition of p-value. Some of you still struggle with that. As is always the case, if the p-value is low, we reject the null. We can have a one-sided test that's an upper tail test, a one-sided test that's a lower tail test, or a two-sided test. And which of these we have depends on the alternative hypothesis. All right, folks, let's shut this down and get ready for page 3.